First step is we need to grab a hold of all of the elements that we will be using. So I'll just use our let keyword. We could use const_var in this instance because we're not changing, but for simplicity, I'm just going to use let for all of my variables today. So let computer equals document dot query selector, and then the selector I'll be looking for in this case will be computer. So I am grabbing the element with the ID of computer, thus we use the hashtag. Now because apparently I'm having some issues typing, I am going to grab my next two elements by copy pasting through. I'm going to use the shortcut for it. If I click the first one to select the second one, I can hold down Command and Option, Control Alt on Windows. That selects both of those elements. Now I can just type once, and I will type human. I will repeat that on the final one here, and this will choose button. So button query selector, the element with the ID of button. So this is a quick and easy way to grab this project. We only have 3 HTML elements that we are working with, so we only need to access 3 using the query selector command. Generally, if we are modifying our document with JavaScript or doing something with it, we are going to use query selector to access any and all elements that we need access to in our document. Extra variables that we will need to work on this project. I'm going to set a variable up for the computer's message, and I'm going to set a variable up for the human's message. We will have additional variables down the road, but those will be enough to get us started in the project. Our event listeners, now that we have control of objects through JavaScript, we will attach event listeners to those items. And the first one that I want to attach to is my button. I will choose button, add event listener. The event I'm looking for is a click. And then I am going to call my click handler function, and this event does not bubble, so I type false. One other item that is going to have an event listener will be the window, and we will be listening for the key down event. And with that, so key down is all lowercase, it's not camel cased. Then I will have my key down handler. So it's a common naming convention that when we are using event handlers, we make a function by the title of the event type, and we then append on the word handler so we know specifically what that particular function is doing. So this will allow us, when we're typing, we don't have to then type, take our hand off the keyboard, grab the mouse, click on the enter button, or hit tab to make the button the next active field, and then hit enter. We can type and then just hit the enter key, similar to what we did on the previous project. Now the functions. We will define out what click handler is and key down handler so that we have them worked out. So I can just say function click handler. Click handler does not need any parameters tied into it. Throw in my curly braces, and then I am going to call a function called play game. I'm going to have a similar function for key down handler, and this one does need to have a parameter tied into it, so I will use EVT so we can pass the event. So when we call this function, the event that called it is going to get passed into it. So then we can say if the event's key code is equal to 13, which is the ASCII character key for the enter or return key on the keyboard, then once again I will call play game. Because I want to have the same function called by two separate events, I need then these handlers to be able to then reference that one function, that function being play game. And play game is where we will put our primary actions for the game. So play game is where all of the real magic is going to happen in this project. First thing I want to have happen is I want to verify that we're getting to play game. And to do that, I could just log a statement out, but what would make it more fun would be to update the computer message statement to be equal to, and now we have to think of a response. You can decide how friendly or unfriendly your chatbot is going to be. So I've now typed in a response for the computer, and then I can say, computer, I want to update your text content to be equal to the computer message. So we set computer message to be this text string, and then we're going to update the text content of the computer paragraph to be that desired computer message. Again, if we have done this correctly, then if I hit enter, we can see the computer does that. Refresh the page, click the enter button, it works. So we've now proven that we can change text in the computer statement based on both the keyboard action, and it again doesn't matter what I type. If I hit enter, we go here. It also seems that what I may want to do every time I hit enter or in play game, I may want to set human message to be equal to an empty string, and actually that doesn't really matter, but what we can do is we can now wipe the contents of that input field. So we have our human input field. So now we can go human so we can set the value. So every time we type a response, the human part goes away. Which we could set it to an empty value, or we could set it, in this case, to human message as well. Both would be acceptable. Now what I also want to do is when the page loads, I want to make the input field the focus. To make the human the focus right away, we call the focus method. Now when the page loads, the cursors are ready in there, so now I can type whatever I want and enter, and we can see that we have a very less than pleasant computer talking to us because it's telling us to go away. It's not very nice. To continue with the electric dreams, the next thing we're going to do is we're going to construct an array. An array is, according to our MDM web docs, it's a global object which contains list-like objects. So essentially, an array is a collection of similar kind objects. In this case, we're going to put a bunch of strings or short phrases or sentences, if you like, into the array. So we're going to use this array as a way that we can then have a variety of responses that we can choose. And in the beginning, we're going to randomly choose a response to give to the player of the game. So I'm going to call this generic responses. And we define arrays. We use square bracket notation when we are defining an array. And then we can put the objects that we are doing into this, and we use commas to separate them. So if I have first, second, third, I've got to put that in quotes because I'm looking for strings. Now I'm going to replace these with better things later, but we're going to just start with this, and then you'll be able to write your own kind of personality when we update this. So these generic responses, these are words, they're strings. We use the square brackets to designate the elements in the array. We separate the elements with a comma. Now we can access the elements in this array by using numbers. The first element in the array is at position 0. So if we say, I want the item in my array at position 1, that would give me second. So it's a little bit confusing sometimes, but what we have to remember is computers like to start counting from 0. So the first element in my array is at a position of 0, position 1, position 2, position 3. So I have 4 elements in my array, and their positions are 0, 1, 2, 3. So the position numbers in my array are always 1 less than the number of objects in my array. We are able to ask a question of JavaScript and say how many items are in the array by using the word length. So I'm going to just log out a couple statements here. You don't need to do this in yours, but I'm going to do this just to quickly demonstrate a few of these things. So now if I say generic responses, first log, log generic responses. So if I save this and go back to my page, I will see that it now logged out the number 4 and all the items in the array. Now if I say generic responses.length, it will just give me the number 4. If I want to access a specific element in my array, then I do it using square bracket notation. So that would look like this. So if I say log out generic responses, the item at position 2, 0, 1, 2, we should see the word third appear in the console. And sure enough, there it is. 2 more variables that we're going to work with and we will be using as we play our game. And I don't want to just keep reconstructing these every time we play the game, so I'm just going to create placeholders right now. One is going to be our new response, and the other one is going to be our response number. Now, we could certainly get by without using these extra values, but our code would be less human readable. It would be a little more machine readable. It would be more compact, but then when you are trying to mentally decipher it, you would have to think your way through as to what is happening in it. So I find it works a little bit better to instead use a few more variables as we try to put the code into the game. So now instead of setting the computer's message to a fixed value, I'm going to set the computer's message to one of the elements in my array, which is why we will go back and rewrite those in a little bit. But first we are going to prove that we can do this. Within JavaScript, we have the ability to generate random numbers. And the way that we're able to generate a random number, I'm going to set my new response. It's going to be equal to a random number. Now, to make a random number in JavaScript, I use the command math.random. Math.random gives me a random value between 0 and 1. So it goes from 0 and up to, but not including 1. So right now, I'm just going to log this out so we can see what that looks like, because we're going to build a number that we can use to grab an element from our array. So I'm just going to log this out. Every time I hit play game, it's going to give me that. So we can see each time I'm playing the game, I am getting a new random number. The first one was almost 1, 0.99918. And our smallest, let's see, 0.08. So we're getting a nice diversity of value here. We're not getting 1, and we're getting these long random numbers. Now if I take math.random, and if I were to multiply it by the length of generic responses, now let's see what we get. So every time I'm playing the game, I'm getting, if I forget and just pretend that nothing is after the decimal point, what you'll see is I'm getting numbers of 0, 1, 2, and 3. I'm not getting 4. I'm not getting 5, but it's 0, 1, 2, 3, and then a bunch of stuff after the decimal point. When we want to only round down, first I'm going to highlight my whole thing, and this is why a code editor is nice. Then I hit the parenthesis, it puts it all in parentheses. And now I'm going to use the math operation of floor. Math.floor rounds all of my values down. Math.ceil, short for ceiling, rounds my values up. Math.round does what we're used to on round. Less than 0.5 down, greater than 0.5 up. But we want to always round down. So we say, I want to floor this. So I'm flooring the random number, 0 to 1, times the number of options I want, the length of my array, which is 4. And now if I run this, I will see I am getting 0, 1, and 2, and 3. So now it's working. Now we get a lot of repetition here, and it's repeating things, so we're going to have to work with that as well. But we'll cross that bridge when we get a little closer to it. Setting the computer message to go away, I'm going to set my computer message to be equal to my generic responses, and this time I will say my new response. So now if we run this, we'll see that we're getting a variety of answers, a lot of repeating. Now if we have more than just the words, it's easier to see. But that repetition is a problem. So after we have used a response, then what we want to do is we want to remove that response from our array. Now I'm going to use the splice command, and I will say generic responses splice, And the item I want to resplice, I'm going to say at the position of my new response that I just used, and I will remove one element. What I'm also going to do is I'm going to log out generic responses after I've done this, just so we can see what's left. And I'm not going to keep logging out whatever one I did. So splice will remove that element because new response is the position in the array, and I'm removing one element when I do it. Save this. And now if I run it, well, see, I have first, third, fourth because it was second. Now if I run it again, I have first and fourth. It put third in this time. If I run it again, now it's fourth remains, and I did first, which means the next time I run it, there's only one possible option it's going to give me, and that will be fourth. Sure enough, there it is. Now we can see the array is empty. There are no more responses. Now if I hit it again, it's trying to splice, but there's nothing there because we don't have anything left to get rid of. What happened is when I play the game, I want to first check and see if any responses are left in the array. And if there are responses, then we're going to play the game like this. If there are not responses, then we're going to go into our Endgame sequence. So we can do that by saying if generic responses.length is greater than 0, we want to do something else. We're going to do our endgame response. So after I've typed that, making sure I have all of my curly braces in place, I'm going to copy up to but not including the closing curly of the function, so just all of my new response and message statements. I'm going to cut those and paste those in so that we perform this action when we have available answers. And then I'm just going to log out game over message if I try and play the game beyond that. So if my generic responses length is greater than 0, we're going to make it happen. So now if I play, so we have, and then the final one, now we're stuck on game over. So we can see we went 3, 2, 1, 0. So I dumped into the game over. So we don't need to log that out. We want to do something else instead. So I want to, in this instance, set my computer message to be equal to whatever snarky comment you want to say. So you could be friendly, you could ask them to politely leave or do whatever else you want to do on it. So we can change the computer message here. And I'm going to demonstrate what we can do next, but then point out why it's probably not a good idea and how we will want to modify our play game just a little bit from what we have. Because if I say computer text content equals computer message, what I will see is I have two lines that are the same inside this function, or inside this conditional. So in both halves of the conditional, I'm doing the same thing, which tells me I don't need to do that inside the conditional but should do that outside the conditional because right now that's repeating code. And a general principle in programming is do not repeat yourself. So if I'm repeating myself, that means there's probably a better way to do it. And the better way is I can now just take this out of here and put it right at the end of play game, get rid of the one up here. So both set computer's message statement, and then after we've run this conditional, we follow up with that computer message. To build in the ending to our game, what I want to do, I'm going to make the function first, and then we're going to call it inside our play game function. So this will be my function kill game. And what kill game is going to do is it's going to change the location of what page we're currently on. Now you can put in whatever URL you want to in here. So you can go find whatever page on the internet makes you happy. I mean, the Apple Store doesn't make me happy, but it's a link I know offhand. I could just go to Google, or I could choose something that's more appropriate to what I am doing. So I've set a location for where I want this to go when I decide to kill my game. Now, to kill the game, what we're going to do is we're not going to immediately kill it. I am going to then use set timeout, and then it will call kill game, and I want to do it in 2 seconds. Now, time on computers is generally measured in milliseconds. So when I use 2000, that is 2000 milliseconds. Each 1000 is a second. So after 2 seconds, it will call the function kill game, which will change my location. So now if I save this and play the game, we can see we get through, and now it's done with me, and 2 seconds later goes to that new location. Location assign is fairly benign. It's considered an acceptable JavaScript way of going somewhere. What we don't want to do, we can also use replace. Replace is bad, because if I use replace, and oh, I had to do one more. Here we go. 2 seconds. And now the page I came from is gone. It doesn't remember it. It erases it from history. So it replaces that page in my browser history with the new location. So that would be bad form unless you have a hostile computer AI that you're building, and then it might be part of its personality. Put it in display none as my class. Now what I'm going to do is when I am playing the game, when it's time to ditch those things and I don't want the player to be able to provide any more input or click the button again, at that point I will say button class name is going to be equal to display none, and human class name will also be equal to display none. And that is how I will make those go away when the game is over. Action. And now we can see it's gone, so I can't press anymore, and I'm stuck waiting for it to go away.